Hi, we're going to start a series of about maybe 4 or 5 different steps or videos on solving equations. Each video or each successive step into a new section is going to bring us one more notch more complicated in the equations. For today, I bet you'll think these are pretty easy, but it's a good time to make sure you get good fundamentals in your work so that you can adjust to the problems when they're more difficult later. So we're going to start with this equation up here, and you can probably just daydream up the answer and know what x is supposed to be, but let's think about the work that you should show. Your goal in any equation is to get x by itself, or the variable by itself. So I always ask myself, if my goal is to get x by itself, what's attached and how do I need to get rid of it? Well, the plus 4 is attached, so I do the opposite, which is minus 4. And I make sure I do it to both sides of the equal sign, or both sides of the equation, to keep things in balance. And now 4 minus 4 is 0, 8 minus 4 is 4, and I have my answer. But you knew that. What you should be concentrating on these problems is showing your work very, very clearly. This one, my goal is to get x by itself. What's attached? The 3. It's attached by division. So what I will do is I will multiply the right side by 3, multiply the left side by 3 so it's in balance. The numerator and the denominator reduce, and I'm done. My goal is to get x by itself. 7's attached by multiplication. The opposite or inverse operation of multiplication, division. So I divide each side by 7. Those reduce. Life is good. But notice how in every single problem I'm doing, you're seeing my work on both sides of the equal sign. Okay, let's spice this up a little bit. I've got a fraction. There's a 2/3 attached to the x. What you should do when you see fractions is multiply each side by the reciprocal. So I'm going to recopy the 2/3 x equals 15. But now I'm going to multiply the left-hand side and the right-hand side by the reciprocal. The reciprocal of the 2/3 is 3/2. So my thinking is, if I want x by itself, I get rid of a fraction by multiplying by the reciprocal, and I do it to both sides. Now the reason the reciprocal works, denominator and numerator reduce, denominator and numerator reduce. And over here, I end up with 45/2, or that's the same as 22.5. And remember, you can have access to a calculator or get used to doing the online calculator if that type of mental math is not your thing. My goal is to get x by itself. There's a fraction attached by multiplication, so the reciprocal is 4/1. So I'm going to recopy this. I'm going to say 4/1 times -6 and 4/1. I'm going to put those parentheses there so we don't think it's subtraction. The left-hand side is -24 because 4/1 is really just a 4, so it's 4 times -6. And here it happens just like we thought it should happen. Oh, well, I'm going to come back to this in a second. I kind of messed up. Let me go back right now. See that negative sign? I should have a negative sign on my reciprocal, which means I need a negative sign right there. And now a negative times a negative is a positive, positive 24. And if I multiply the left side by -4/1, I have to multiply the right side by -4/1. So this is looking pretty complicated. But I would have a reduce and a reduce, and this negative times this negative, remember a negative times a negative is a positive, so this whole mess ends up being +1 or 1x, and I get to just write x. So the answer is 24. The idea was reciprocal attached to the variable, a fraction attached to the variable, multiply by the reciprocal, on one side and the other. All right, let's finish with these last two. My goal, get x by itself. This is going to take a couple of steps as opposed to the previous ones, which happened really in one step. If I want to get x by itself, I have to get rid of the -3 and the multiply by 5. The rule of thumb that you should adopt is this. Generally speaking, you want to get rid of the further away from the variable item first. So this term, -3, I'm going to add 3 because -3 plus 3 is going to be 0. And if I do it to the left side, I must do it to the right side to keep it in balance. When I do that, I didn't do anything to the 5x, so that comes down to the next line. A 37 plus 3 is 40. So what I've done is I've taken a more complicated equation, and for one step, I've made it a little easier. My goal is still to get x by itself. I still ask myself what's attached and how is it attached. So the 5 is attached to the x by multiplication. I will divide, reduce, and x equals 8. Let's do one final one. My goal is to get this x by itself, but there's a divide by 5 and a subtract 5 attached to that x. The rule of thumb, get rid of this one first because it's further away from the x. And how do you get rid of a -5? You add 5. You do it to the right side, you do it to the left side, and your work should be all lined up so that it's very clear what's happening. On the right side, I'm left with x over 5. On the left side, -8 plus 5 is -3. If you don't like that mental math, don't be shy about your calculator. My goal is x by itself. This is a 5 that's attached by division. I will multiply. And I will multiply over here so that I don't mix up my ideas. This is a -3 times 5. Sometimes putting parentheses makes you not make the mistake of thinking it's a 5 minus 3. -15, numerator, denominator, reduce. And I have the answer. Let me show you one little more pro tip. Anytime you get to a final answer, you can check yourself by plugging back into the original problem. So I'm going to take 5x minus 3 equals 37. And I thought 8 was the answer. I'm going to go ahead and plug 8 in for x. And if 8 is a correct answer, this is going to work out to give me a true statement. 5 times 8 is 40. 40 minus 3 is 37. As Homer Simpson would say, math checks out. I now know x equals 8 is a valid answer. I could do that with every single one of these problems on this sheet. That concludes the 1 or 2 step equations video. Let's make it a little bit more complicated on the next one.